So in our previous class, we've discussed about the sight distance. We have solved some numericals on the sight distance. So in this class, we will discuss about the overtaking sight distance, and after that, we will solve some numericals. Now, if you go for the overtaking sight distance, in that case, overtaking sight distance is the visibility required for a driver to overtake a vehicle. So generally what happens when you are driving your vehicle and when you intended to overtake a particular vehicle, in that case, you need to check whether any vehicles are moving from the opposite direction or not. Okay, and you have to observe that and analyze that what should is the speed which you need to follow to overtake that vehicle. Okay, so there are different operations or different analysis in that overtaking sight distance. So basically, in some cases, that overtaking sight distance is required. Why it is required? Because in our Indian condition, there are different type of vehicles which are moving over the road. There are some slow moving vehicles, there are fast moving vehicles, etc. Now, if there are slow moving vehicles and if no overtaking operation is permitted, in that case, there will form platoon of vehicles. Platoon of vehicles means suppose one slow moving vehicles are there and if basically running very slowly, then after that, if it is not if there is not any permission for the overtake, in that case, there will be line of vehicles which would be behind this. So for this type of reason, overtaking operation is allowed and we need to provide overtaking sight distance whenever it is possible in the stress of the road. Now there are different factors which overtaking sight distance depends. So these factors are, the first one is speed of the overtaking vehicle. Overtaking vehicle means suppose you are uh, running with a higher speed and you intended to overtake another auto rickshaw or suppose tom-tom or whatever a slow moving vehicles. Then speed of the overtaking vehicles means speed of your vehicles. Overtaken vehicles means which vehicles you want to overtake, and if there is any vehicles coming from the opposite direction, in that case you have to uh, consider the speed also. Otherwise, in that case, there will be chances of head-on collision with the opposite moving vehicles. Then skill and reaction time of the driver. If the skill and reaction time of the drivers are good, if the reaction time of the driver is less, in that case he can react very easily. Okay, and within a short span of time he can overtake. Okay, then distance between overtaking and overtaken vehicles. What is the distance between these two vehicles and how much distance you have to cover before overtaking? Then rate of acceleration of overtaking vehicles, that is how much you are accelerating your vehicles to overtake that, and gradient of the road if there is any. Now here, this reaction time of the driver is considered as 2 seconds for overtaking operation. Now, this is one overtaking analysis of the overtaking sight distance. Suppose this is a two-lane road. Now, this vehicle B is the slow moving vehicles which you are going to overtake, and vehicle A is the fast moving vehicles which is overtaking vehicles, and B is overtaken vehicles. Now, this A1, A2, B1, B2, A3, etc. are the position of vehicle A and B in different time lapse. Okay, and vehicle C is coming from the opposite direction. Now, if you go for the total analysis of the overtaking sight distance, in that case, what happens initially, that is a vehicle A. Suppose this vehicle A is moving with a higher speed. Okay, suppose that vehicle is moving with a design speed. Okay, and that design speed is suppose VA meter per second. and vehicle B is moving with a lower speed. Suppose the speed is VB meter per second. So initially what will happen, that vehicle A will initially come to position A2. Okay, he will observe the speed of the vehicle B, and whatever speed he initially maintained, he will reduce his speed and follow the vehicle B. Okay, and maintaining a clear distance between them, that A2 and B1, that maintaining a clear distance between them. So basically it is assumed that from A1 to A2 the vehicle A covers the distance with a time, that time is equal to his reaction time. So within that reaction time, what happens, this vehicle A or fast moving vehicle will initially reduce its speed, okay, follow with the uniform speed behind vehicle B, or he will maintain a speed which will be equal to vehicle B and follow the vehicle B with a clear spacing S, and he will look for any opportunity to overcome the vehicle B. Okay, so that is the concept of this thing. So initially, suppose before that position, before this position, that vehicle A has a speed of suppose VA meter per second or V meter per second, that is the design speed. But whenever he is seeing that vehicle B and he tries to overtake, in that case he will force to reduce his speed, which is equivalent to the speed of the vehicle B VB, and he will follow the vehicle B until he gets chances to overtake the vehicle B. And this time from A1 to A2, that is that time, it is assumed that he overtakes that time within his reaction time t second. Okay, so this distance, that is d1 distance, that from A1 to A2, that distance would be VB into t, or 2 into VB, because here reaction time is 2 seconds. Now after that, what will happen, then vehicle A will initially, it will change its lane. Okay, initially its speed is VB. After that, in that position he will accelerate, it will accelerate, change its position from this position to here, overtake the vehicle B, and again going to its original lane. Okay, now from here to here, basically that is your actual overtaking operation, and that total distance is d2. Here also that vehicle B and vehicle A will maintain a clear spacing, and that's clear spacing S is 0.7 VB plus 6. Now you have to analyze this distance. So if you analyze this distance, that suppose from B1 to B2, that that portion is suppose B, and that clear spacing in both the cases is S. So your D2 would be B plus S, that is D2 is B plus 2S. Now during this overtaking operation, suppose the total time taken for the vehicle A to move from position A2 to position A3 is capital T second. Suppose that is capital T second. So basically capital T second is nothing but the actual time for the overtaking operation. Now during this capital T second, that vehicle B is also moving from position B1 to position B2. Okay, and this is the position of a vehicle moving from the opposite direction with a speed of V meter per second, and he and that vehicles moves with a design speed, that is V meter per second, during the overtaking actual overtaking time, that is capital T seconds. So let us go for the analysis of that overtaking side distance. I think this portion is clear to you, otherwise I will discuss it again. Better I will discuss this again. So basically what happens, listen carefully, this is very important thing. So basically there are two vehicles A, B, in the same lane, vehicle B is the overtaken vehicles and vehicle A is the overtaken vehicles. The speed of the overtaken vehicle is more and speed of the overtaken vehicle is less. Suppose the design speed of that road is v meters per second and the speed of the overtaken vehicle, that is slow moving vehicle, is vb meter per second. So initially what will happen? Initially the vehicle A will follow the vehicle B, maintaining or forced to reduce its speed from design speed to the speed of the vehicle B. Okay, so that distance from A1 to A2, that distance is equal to Vb into t second, where t is the reaction time of the driver. Now after A2 to A3, that is your actual overtaking operation, and suppose that overtaking operation has been conducted within a time of capital T second, and within that capital T second, vehicle C moves from C1 to C2 position, and during the T second also vehicle B1 moves from B1 position to B2 position. So basically that is the thing. Now we have to go for the analysis. So D1 we have already discussed about that D1. So that's the overtaking operation can be divided into three parts: D1, D2 and D3. D1, the distance traveled by overtaking vehicle A during the reaction time T second from the position A1 to A2. D2, the distance traveled by the vehicle during the actual overtaking operation A2 to A3, and D3 is the travel distance traveled by the opposite moving vehicle in capital T second from C1 to position C2. So your overtaking side distance is basically D1 plus D2 plus D3. Now from A1 to A2, as we have discussed, that distance is D1 equal to Vb into T. Now we have discussed that this distance, that is the distance between vehicle A2 and B1 and B2 and A3, that particular distance is the clear spacing which these two vehicles are maintaining. Okay, so this clear spacing is basically denoted as S, and which is equal to 0.7 Vb plus 6. Okay, 0.7 Vb plus 6. So your D2 would be, your D2, that is D2 would be B plus 2S, and you already found what is the value of S. Okay, now what you have to find out? You have to find out what is the value of B. Now, during that time, vehicle A accelerated from initial velocity Vb, and overtaking is completed while reaching final velocity V. Okay, so what happens at that position A2? What was the speed of the vehicle A2? That was Vb meter per second, because it was forced to reduce its speed from V to Vb. Okay, after that it accelerates. Suppose that rate of acceleration is A, and after acceleration it reached to position A3. Okay, with, and at A3 it's reached its final speed, which is your design speed, that is V meter per second. So here your D2 would be Vb into T plus half AT square. That is your formula. I think you are all familiar with this formula, that is in from your 9th or 10th standard. So basically D2 is Vbt plus half AT square, and you know about D2. D2 is basically 2s plus Vbt. So from this equation you can easily find out what is the value of T. So basically the value of T is root over 4s by A. So you put all these value into this equation. So basically your D2 is 2s plus Vb into root over 4s by A. Now all these values are your known values. Okay. Now what about the D3? D3 is the distance traveled by opposite moving vehicles from position C1 to position C2 within that particular overtaking time of capital T second. So T3 is V into T. So therefore your overtaking side distance is Vbt plus 2s plus Vb into root over 4s by A plus v into t. So that is your overtaking side distance. So let me discuss this again. So if you go for the analysis of this distance, so initially the speed of the vehicle A was v meter per second, but its speeds was reduced to vb meter per second. So from position A1 to A2, that distance d1 is equal to vb into t, where t is your reaction time, and in the overtaking cases that t is considered as 2 seconds. So your d1 is vb into t. Now what about d2? So basically your d2 is b plus 2s. Okay, that is basically b plus 2s, whether s equal to 0.7 vb plus 6. Okay, that is the value of s. So how to end your d3 equal to v into capital T, where t is the actual time for that overtaking operation. That is basically t is the time when that vehicle A moves from position A2 to A3. Okay, now that position we can also write as like that, your d2, if the acceleration of the vehicle A is A, in that case it is vb into t plus half a into t square. Okay, so that is also equal to d2 is also equal to your b plus 2s, that is equal to vb into t. Now it is square. Okay, now how to further calculate? So lastly we got that our d plus 2s equal to d plus d square. Now if you consider about that vb into t, so basically that is basically nothing but b. because if the speed of the vehicle v is vb and within that total overtaking operation, that vehicle b is moving from v1 position to v2 position. So instead of b, or instead of vb into t, you can write down b. So basically that two portion is equal, so you can cut it down. So from this equation, you can get your value of t is nothing but root over 4s by. Okay, so after that you put all these values and you will get the final equation. So your overtaking side distance is d1 plus d2 plus d3. Is it clear? I think that portion is clear. So another thing is overtaking zone. So whenever that overtaking side distance in some portion of the road, it is not possible to provide. In that case, you need to provide some designated overtaking zone whether that vehicle can overtake. So that designated overtaking zone, the total length of that overtaking zone should be 3 to 5 times of that overtaking side distance. So first you have to find out what is the overtaking side distance, and after that the total length, okay, total desirable length of that overtaking zone would be 5 times of the overtaking side distance, and that minimum length of the overtaking zone will be 3 times of the overtaking side distance. Okay. Now here another thing is there, that whenever you are designing a overtaking zone, in that case you have to provide signpost. Okay, you have to provide signpost to uh, make it know for the drivers that a overtaking zone is ahead of his current direction. So in that case, one overtaking that signpost should be provided at the entry of the overtaking zone at a distance of overtaking side distance from that particular starting point. After that, he enters that overtaking zone. Now, at the end point, also, there should be one signpost which indicating that overtaking zone will be shortly finished, and that distance where it will be installed, that would be at a distance of total overtaking side distance from the endpoint. Similarly, for the opposite direction also, you need to go like that. So this type of dedicated zones are called overtaking zone. Okay. So suppose there are some questions. Suppose if a overtaking side distance, you are getting a overtaking side distance of 100 meter. In that case, the desirable length of the overtaking zone would be 5 into 100, that is the 5 times 500 meters. Okay. And the minimum length of the overtaking zone would be 100 into 3, that is 300 meter. Now the distance of the signpost, the position of the signpost would be for the desirable one or for the minimum one signpost would be at a distance of 100 meter from the start of that overtaking zone, and another would be at a distance of 100 meter before the ending point of the overtaking zone. I think this portion is clear. Okay. So let us solve some numerical.